So next example, given that 2 points A and B have position vectors as shown, we have to find a unit vector along the direction of AB and find the angles it makes. Okay, so position vectors of A and B, let's say RA and RB, are given to us. Now we have to find the vector AB. From that, the angles of vector AB with respect to the three orthogonal axes or the XYZ axis. Do you really understand what's exactly being asked in this question? So let's say this is the point A and this is the point B. Okay. Now you have to imagine that this is actually in a three-dimensional situation. So the points A and B don't actually lie in the XY plane. So the point A, you can see, has coordinates 1, 1 and 1. So it's lying outside somewhere over here. And the coordinates of the point B are 5, -3 and 1. So it's again lying somewhere over here because it has a negative y coordinate and a positive x component, etc. Now in this diagram, the vector RA would be this one, is the position of A with respect to the xy system, the coordinate system. So it would be so RA would be nothing but the vector OA, right, from the origin to A. Similarly, RB would be this vector here. Now we want to find out the vector AB, that is a vector joining A with B. Right? So starting from the point A, the displacement of the point B or the position of point B with respect to A would look like this. Okay. So this is basically the position of B with respect to A. Right? So that's the difference. OB is the position of B with respect to the origin, but AB is the position of B with respect to the point A. Now, once you have understood this vector diagram, you will also immediately realize that this vector AB is nothing but the vector difference of OA and O. Right? So, understand that the vector AB is nothing but OB minus OA. Or that is the position of B with respect to the origin minus the position of A with respect to the origin. So the vector AB is nothing but 5i cap minus 3j cap plus k cap minus I plus j cap plus. Alright. So completing the algebra here, we can see that the vector AB is 5 minus 1 of 4i cap, okay, then minus 3 minus 1, so that's minus 4j cap, and 1 minus 1, that's 0, okay. So that is the vector AB. Right. So once we have understood that the vector AB is this, it will be pretty easy to find out the angles, okay. Right. So next up, let's right, so I believe this was what the vector AB was. Okay. So as you can see here, that given any vector, the direction cosine with the x-axis can be expressed as the x component divided by magnitude of the vector. So that is 4 divided by mod of 4i cap minus 4j. So that is 4 divided by square root of 4 square plus 4 square. That is 4 divided by 4 root 2. That tells us that cos alpha is equal to 1 by root 2. So that tells us that alpha is equal to 45 degrees. So the angle that this vector AB is making with the x-axis is plus 45 degrees. Okay. Similarly, cos beta is the y component of AB divided by the magnitude of the vector. Right. So the y component you can see is minus 4, okay, and the magnitude we've already expressed. So this is minus 4 by 4 root 2. So cos beta is minus 1 by root 2. Okay. So that tells me that beta is equal to minus 45 degrees. Oh, sorry. Beta is equal to 135 degrees. Or 90 plus 45 degrees. Or 180 minus 45 degrees. Right? So that is the value of beta. And finally, gamma. Now you can see here that AB is in the xy plane, okay, or perpendicular to z axis. Okay. So gamma should be 90 degrees. It's perpendicular to the z axis. Okay. You can also see that cos gamma, right, is equal to EB z component divided by mod AB. So that is 0 divided by 4. So that means gamma is that. So that's just another way to express the same thing. So these become the angles that the vector AB is making with the x, y and z axis. Right? Okay. So the next example involves a diagrammatic representation. So magnitude of OA and magnitude of OB are given to us as 10 and 20 respectively. And from that we have to express in terms of I cap and J cap, or the standard unit vectors. So this is a pretty simple problem, as you can see. So as far as the vector OA is concerned, you can see its magnitude is given to us as 10 and the angle theta is given to us as 120 degrees, right? So the vector OA will be magnitude of the vector OA into cos theta I cap plus magnitude of OA into sin theta J cap. Now magnitude of OA is given to us as 10, okay, and theta is given to us as 120 degrees. So cos theta is cos 120 degrees can be expressed as cos of 180 minus 60 degrees, or minus cos 60 degrees, or minus half, right? And sin theta, which is sin 120 degrees, can be expressed as sine of 180 minus 60, which is sine 60 degrees. So sine theta becomes root 3 by 2. Right, so sine theta there becomes root 3 by 2. Right. So keeping that in mind now, you can see that the vector OA becomes 10 into minus half I cap plus 10 into root 3 by 2. So 5 common. Becomes the expression of the vector OA in component form becomes like this. Right. Now next up, let's look at the vector B, or OB rather. So mod OB was given to us as 20 units, and this angle here, this angle here was shown to us as 30 degrees, right? So what we can understand here is that the angle that OB makes with the x-axis, theta, the anti-clockwise angle, is 180 plus 30, or 210 degrees. Okay. So once again, the vector OB will be expressed as magnitude of OB cos theta I cap plus magnitude of OB sin theta j, where magnitude of OB is given as 20 and theta is given as 210 degrees. Okay, so express that. So next up, we can see that cos theta, cos 210 degrees is cos of 180 plus 30. That will be minus cos 30 degrees, or cos theta will be minus of root 3 by 2. Right, so that's worked out. Whereas sin theta will be sine of 210 degrees, okay, which is sine of 180 plus 30 degrees, right? It will become minus sine 30 degrees, or minus half. So substituting all this information here, you can see that the vector OB is mod of OB, which is 20, into cos theta, which is minus root 3 by 2, plus mod of OB multiplied by sin theta, which is minus half. Okay. This would be one way of expressing the vector OB in component form. Right. Right, so let's pick up another example. So, given a unit vector is 0.3 I cap plus 0.4 j cap plus ck cap. So we have to find the value of c, given that n cap is a unit vector, right? So quite simple, right? Let's see. So n cap is a unit vector, means its magnitude should be 1. So basically, square root of 0.3 square plus 0.4 square plus c square should be equal to 1, or 0.3 square plus 0.4 square plus c square should be 1 square, which is 1. Okay. So now expanding this, 0.09 plus 0.16 plus c square should be equal to 1, okay, or 0.25 plus c square should be equal to 1, which implies that c square is 1 minus 0.25, or 0.75, or we can say 3 by 4. So c is plus minus square root of 3 by 4. So c could be plus or minus of root 3 by 2. Okay. So this has a multiple solution. C's values could be both plus of root 3 by 2 and minus of root 3 by 2. Alright. A force F is given by this, okay, where Fy is equal to 16 newtons and the angle of the force F with the x-axis is 53 degrees. So from this we have to find magnitude of F. Right, so that is the problem in hand over here. So let's work this out. So we can understand that the y component of the force is 16 newtons. Okay. But let's say the x component is some unknown fx like this. So then the force would be this vector here. Now this angle here is given to us as 53 degrees. So if the magnitude of the force is F, so Fy is equal to 16 means that F sine theta is equal to 16 on F sine 53 degrees is 16. As you know, sine 53 degrees is 4 by 5. Okay. That means the magnitude of F becomes 20. So that is another example of the application of component algebra. So let us look at the next one. Alright, so next example is like this, that given that a particle starts moving from the position A, which is 2, 0, 0, okay, in the coordinate frame at a uniform velocity of v equal to 1.5 I cap plus 2 j cap plus 6 k cap in meters per second and stops at t at time t equal to 2 seconds. So we have to find, first of all, the displacement of the particle in the 2 seconds. Then we have to find the position vectors of E and V. Coordinates of. So given this information, these are the various quantities that we have to calculate. So let's understand the application. So as you can see, this is an application of component algebra applied to very basic sort of situation in motion or kinematics, wherein a particle is moving with a uniform velocity. So when something moves with a uniform velocity, it means its acceleration is 0, which means that the displacement is just the velocity multiplied by time. Right? So that is how we will start the operation. So we can see that since velocity is displacement upon time, we are talking about uniform velocity. So displacement can be calculated as velocity multiplied by time, where delta t is the time interval. Alright, so given that the velocity is 1.5 I cap plus 2 j cap plus 6 k cap in meters per second, and the time interval we are considering is 2 seconds, that is t equal to 0 to t equal to 2 seconds. Right? So we can see that the displacement will become velocity into time, so that is 1.5 I cap plus 2 j cap plus 6 k cap multiplied with 2. So since this is velocity is in meters per second and the time is in seconds, we will be getting the displacement in the unit of meters. So this will show us that the displacement that we are talking about is 3 I cap plus 4 j cap plus 12 k cap in meters. Right. And from this we can understand that the magnitude of the displacement will become square root of 3 square plus 4 square plus 12 square, which will become 30 meters. So the magnitude of the displacement will be 13 meters in a matter of 2 seconds. Now we can also note here that since v is equal to displacement upon time, magnitude of velocity is magnitude of displacement upon time. So we can see that magnitude of velocity should be 13 by 2 or 6.5 meters per second, and that is the same thing as mod of 1.5 I cap plus 2 j cap plus 6 k cap. So just another aspect to understand, that if two vectors are related like this, that one vector is some scalar, which is 1 by time over here, multiplied by another vector, so they are proportionate to each other, then their magnitudes are also proportionate by the same factor. So if I say A is equal to 2B, it obviously means that magnitude of A is equal to 2 times magnitude of B. So that is that particular example. So in the next example, we have a force which is expressed in terms of non-rectangular coordinates, components, right? So in the next example, we have a force F of magnitude 12 units has non-rectangular components P and Q. Now it is given to us that Q is at right angles to F and of magnitude 80. So given that situation, Q is not equal to 18. Let's make a correction here. The sum of the magnitudes of P and Q are equal to 80. So given this, and given that Q is perpendicular to F, we want to find mod P and mod Q. And from that, we also want to find. So let's look this up. So basically, the moment we say that F is broken into components P and Q, it means that F is equal to P plus Q. such that P and Q are not orthogonal. Okay, because it was given to us that it is broken into components which are non-rectangular, right? So that means non-orthogonal. Okay. And also it is given to us that Q is perpendicular to F. Okay. So that means if this is the vector F, okay, which is given to us of magnitude 12 units, then the vector Q would, let's say, be like this, and in that case the vector P would have to be like this, so that it works out exactly that P plus Q is equal to F. Right, so this is the basic situation over here. This angle is 90 degrees. Okay. So let's say this magnitude is Q and this magnitude is P. So again this is P. So one thing we have over here is that P plus Q is equal to 18. That is given to us. Okay. That's one thing we know. And the other aspect that we know is that from the right angle triangle, P square is equal to Q square plus 12 square. So this is first equation. So now the solution would involve just solving these two. So solving 1 and 2, we get, for example, P square is equal to Q square, which is 18 minus P whole square plus 12 square. P square minus 18 minus P whole square is equal to 12 square, right? So that we could say is P plus 18 2P plus 18 into 18 is equal to 12 square. So that would give us P equal to, let's do the calculation here. Minus sign of P. That would give us P equal to 13 and Q equal to 5. So that would give us that would be the solution. So that is one way of doing the question. Now we can take an alternate approach to the same problem. By using vectors algebra, vector component algebra. So we understand that F is equal to P plus Q, okay, where mod F is equal to 12 and mod P plus Q is 18 and Q is perpendicular to F. Okay. So once again, this time we'll take our x-axis along F, our y-axis along Q. So since we are talking about the sum of two vectors, so it's a two-dimensional situation. So let's say this is the vector Q. So the vector P, as you can see, has to be this one here. So here what we can say is this is 12. Okay. Let's say Q is has some magnitude q and p has magnitude p. So what we could do here is we could understand that f is 12 I cap, that's numbers, right? And q is some factor q into j cap, and p is p into, let's assume this angle here is some alpha, so it is cos alpha I cap minus sin alpha j. These are now we will solve this equation for the fact that f is equal to p plus q. So that would tell us that 12 I cap, which is f, is equal to this plus this. Okay. So this plus this, as you can see, is p cos alpha I cap plus q minus p sin alpha. Okay. So this is the information that we're getting. So solving this, what we understand is equating the two sides of a vector equation. If vector A is equal to vector B, then the x component of A is equal to the x component of B and the y components are equal. So basically when two vectors are equal, their individual components are also equal. So that tells us that 12 is equal to p cos alpha. So that's equation 1. And q minus p sin alpha is equal to 0. Or equating left hand side with right hand side, what we will get is that 0 is equal to q minus p sin. That's our second equation. Alright. And of course we also have this in mind, that p plus q is equal to pt. So let's say that is our third equation. So solving these, we can easily find the value of p and q. Let's see how. So next, let's say we make use of equation 2 and we get p sin alpha is equal to q, whereas equation 1 was telling us that p cos alpha is equal to 12, right? So squaring and adding these two shows us that p square into cos square plus sin square alpha is equal to 12 square plus q square. Now using the identity that cos square plus sin square is 1, we get p square is equal to 12 square plus q square, right? Get that relation. And of course we already know that p plus q is equal to 15. Right? So now we can make use of that and again solve. So p square is equal to 12 square plus q square, which is 18 minus p whole square. So we get the same equation, p square minus 18 minus p square, 12 square, that which tells us that 18 into 2p minus 18 is equal to 12 square, p is equal to 13 and q is equal to 5. The same solution. Right, so this is an example of the application of component algebra. Okay. So keeping this in mind, let's move on next to the concept clearing problems. Okay. Let's get on with the first one. So the problem here says that we consider east and north as our x and y axis, and that a girl walks a certain distance east followed by a certain distance making 30 degrees west of north, and then a third unknown direction so as to return to her initial position. What is the third displacement? Okay, so the question given to us is that you consider east as the x-axis and the direction north as the y-axis. Now a girl walks 10 kilometers due east, followed by 10 kilometers at 30 degrees west of north. followed by a third displacement. To return to the original position. So we have to find third displacement and how much the third displacement is. Right. So we will approach this problem by component method. So what we see here is that taking the x-axis as east, the y-axis as north, for the negative x-axis as west, and the negative y-axis as south. Okay. By taking this coordinate frame, we can see that the first displacement, okay, is 10 kilometers due east. So S1 we can denote by a vector like this. Okay. The second displacement is 10 kilometers at a direction 30 degrees west of north. Okay. So this is my north direction, this is my west direction. So I have to turn 30 degrees west of north. Okay. That means from my northern direction I would turn 30 degrees towards the west. And that would be my displacement of S2, which is again of magnitude 10 kilometers. Right. And the third displacement S3 we have to calculate. If S1 plus S2 plus S3 is equal to 0. So that is the problem statement simplified somewhat to a geometrical vector representation. Now next, instead of converting it into a polygon law type of application where the sum of three vectors is 0 means that they should be forming three sides of a triangle and thereby calculating S3. That is also doable, but here what we'll do is we will consider component algebra and we will convert these two vector diagrams into component form expressions of vectors S1 and S2, and we will solve this equation to find S3 in component form, and from that we can predict its direction and magnitude. Right. So let's continue ahead. We have got so far, what we can understand is S1 is a vector which is strictly along the x-axis. So S1 should be written as 10 I cap in kilometers. Right. Now similarly, S2 is a vector that is lying over here, where this angle is 30 degrees, its magnitude is 10 kilometers. Okay. So how would we express S2 in component form? So you can see that if you draw perpendiculars here, this angle being 30, this angle is 60. So this component here would have a magnitude of 10 cos 60, or that is 5. Whereas this component has a magnitude of 10 sin 60, or same thing as 10 cos 30, so that is 5 root 3. Right. So that means we can express the vector S2 as 5 units along the negative x-axis, so minus 5 I cap, okay, plus 5 root 3 units along the positive y-axis, so that's plus 5 root 3. Right, so that gives us the vector S2. Now we want the third vector S3 such that when we sum up these, S1 plus S2 plus S3, you get 0. That is the situation. So if S1 plus S2 plus S3 is equal to 0, naturally implies that S3 is negative of the sum of S1 plus S2. So in other words, S3 is negative of S1 plus S2 this here shows that S3 is equal to negative of 10 minus 5, so that's minus 5 I cap, okay, and negative of 0 plus 5 root 3, so that's minus 5 root 3. Okay. So that is the vector S3. I would also show that for the vector S3, its magnitude would be kilometers, and the direction it's making with the x-axis would be tan inverse of minus 5 root 3 divided by minus 5, so that is third quadrant. Okay, so that would be 180 plus tan inverse root 3. So 180 plus 60 or 240 degrees. Now this should be pretty evident also. So basically we have solved the problem when we have come to this step over here. But just analyzing it a little bit further, we can see another interesting thing. Okay, that is, having solved it this way, okay, we just want to go by the interpretation a little bit more. We can see in the interpretation of the problem that S1 was of magnitude 10. S2 was also of magnitude 10. And this angle was 60 degrees, which means that this angle was 120 degrees. Now we have to find the third side of this triangle, is S3, and find its magnitude and direction. Okay. Now if we go by simple geometry also, this is pretty easy, because you can see these two are same. Right? So that means these two angles are the same. So let's say they are alpha and alpha. So easily you can see that alpha is equal to 60 degrees. So it's an equilateral triangle. So that simply tells us that magnitude of S3 will be equal to mod of S1 or mod of S2 or 10 kilometers. So that agrees with what we've seen earlier. Right. And also you can see that alpha being 60 degrees, you can see that over here, this angle theta, okay, how much will this become now? So you can see that this is 60 degrees, right? So theta is 180 plus 60 or 240 degrees, which again agrees with senior. So that is interesting interpretation of the result that we got by component algebra using simple concept of equilateral triangle. Okay. So let's consider the second example now. So the second example says consider east as positive, north as positive x-axis, north as positive y-axis, and vertically upward direction. So now we are taking 3 dimensions into account. So on a horizontal plane, right? On a horizontal plane, if we have direction pointing towards me as north, this direction as east, so this is north and east. So we consider the eastern direction, that is this direction, as our x-axis, the northern direction as our y-axis, so the one pointing towards me is the y-axis, and the z-axis becomes the vertical, as you can see. So north, south, east, west, they lie in a horizontal plane, and the vertical is an axis which is perpendicular, mutually perpendicular to that. So taking that into account, okay, this is talking about the motion of a helicopter. So it says it first rises up to an altitude of 100 meter, then flies straight north by 500 meter, then suddenly takes a turn east and travels 1000 meter. So we have to find the position vector of the helicopter with respect to the starting point. The question says that, again, we take the east as our positive x-axis, northern direction as our positive y-axis, and the vertical as our z-axis. Right, so that is the convention that we are using, or the notation that we are using for our x, y, z rectangular coordinate system. Now it says that a helicopter, okay, moves vertically by, what was it now, 100 meters. So it gains an altitude of 100 meters. Okay. Then from there on, once it's gained an altitude of 100 meters, it flies straight north. So due north by 500 meters. Okay. And then takes a turn towards the east and travels 1000 meters. So, and then due east by 1 kilometer, 1000 meters. So we have to find the position vector of the copter with respect to its point of origin. Right, so let's say we have to calculate that. Now, going by this, we can see that you can think of this like the first displacement the copter is making, and the first displacement is vertically upwards. So the vertical direction has been taken as the z-axis. So this 100-meter component will for us be lying along the unit vector k cap. So this is the first displacement S1. Then the second displacement is due north, and north for us is the y-axis. So immediately after completing the vertical displacement of S1, the helicopter is making a second displacement which is due north, that is S2 of 500 meters. So S2 can be expressed as 500 j cap in meters, right? Because the northern direction is our y-axis. Now similarly, following that northern displacement, the helicopter makes a third displacement which is due east by 1000 meters. So due east by 1000 meters means that we have to take it along the x-axis or along I cap, and its magnitude is 1000. So this will become 1000 I cap in meters. So as you can see, to find the final location of the helicopter from the original point to where it lands up after making, or where it ends up after making 3 successive displacements, we can say that the net displacement is equal to the sum of S1, S2 and S3. Right? So as you can see, that will become 100 K cap plus 500 J cap plus 1000 I cap. So now the thing is, since we are taking the origin as the point of origin of the helicopter and the final position as the position it reaches after this displacement, we can say that the position of the helicopter with respect to the origin is nothing but this vector. So the position itself is the net displacement. So that is 1000 I cap plus 500 J cap plus 100 K cap. And for example, the magnitude of its displacement will become square root of 1000 square plus 500 square plus 100 square, which we can express conveniently as 100 times square root of 10 square plus 5 square plus 1 square. So that is 100 square root of 126. Fine, so that is the second question of the concept clearing problems exercise. Now let's move on to the third one. Alright, so the third problem states that we are given a force in component form, and we are given that it produces an acceleration of a certain magnitude which is given, and from this information we have to calculate the mass of a given body. So this comes down to an application of Newton's second law. So basically it says that a force F of 6 minus 8 and plus 10 produces an acceleration of 1 meter per second square. So this force is in newtons. This much force in newtons produces an acceleration of 1 meter per second square when applied on a body. So we want to find the mass of the body. So this is again a standard situation of the application of Newton's second law, okay, where we know that second law of motion states that the net force acting on a body is equal to rate of change of momentum with respect to time. Okay. Now here, since the mass of the body is constant, we'll assume it's a rigid body. This conveniently translates to the fact that the net force can be written as mass into acceleration. So this can also be interpreted as magnitude of the net force is equal to mass into magnitude of the acceleration. So mass, which is a scalar, can therefore be expressed as the magnitude of net force divided by the magnitude of acceleration. Right? So given that the net force is the force F that is acting, so it's 6 minus 8j plus 10k in newtons. It means that magnitude of the net force is magnitude of this vector, so that's that much. So as you can see, that will become square root of 36 plus 64 plus 100, or square root of 200, so that is 100 root 2 newtons. So that is the magnitude of the net force, and acceleration's magnitude is given to us 1 meter per second square. Again given. So using these values, we can see that the mass, which is magnitude of force upon magnitude of acceleration, will be nothing but 100 root 2 kilograms. Right. It will be 10 root 2. Just a correction here. So this is square root of 200, or 10 root 2. Make sure you've got this correction noted out. And once you got that, you can see that it's the third problem. Okay, let's move on to the fourth one next. Understand this. So it says that a bird moves from a particular point to another, which are given in coordinates, and also the speed of the bird while it's moving is given. So from that we have to find the velocity vector of the bird. So find the velocity of the vector. Okay. So let's understand this a bit of a diagram. Let's say this is our xy plane. Now the bird is moving from an initial point which is 1 comma minus 2. Right? So 1 comma minus 2 would be, let's say, somewhere over here. It's moving from, let's say, the point A to a final point which is 4 comma 2, so that would be, let's say, somewhere here. This is the final point B. So we can say that the displacement of the bird is along this particular line. So that is the displacement vector of the bird. Now we know that velocity would be displacement divided by time, because it's a uniform velocity. We'll assume that we are talking about a uniform velocity over here. So the velocity vector over here would be along this direction. Also, we can say that the velocity vector is the magnitude of velocity into the unit vector. Okay, so magnitude of velocity is nothing but speed, which is 10 meters per second given. And v cap is the unit vector of velocity. So now what we can see is that since velocity is proportional to displacement, okay, you can see that velocity's unit vector will be along displacement's unit vector, because the fact that v is proportional to s means that they are parallel vectors, and parallel vectors means that they have the same direction, which means that they have the same unit vector. So first of all, you can also see here that the displacement is the displacement from E to B. Alright? So the displacement vector has an x component of, you can see this is 1 and this is 4. So it has an x component of 3. Okay? And a y component of, you can see that this point here is minus 2 and this point here is 2. So the y component of displacement is minus 2 to 2, which is also 4. Okay. So the displacement we can see from the diagram is 3i cap plus 4j cap in whatever unit. So these are the pieces of information that we have. This and this is what is given to us directly. Now from this we want to find the velocity. So we already know that the magnitude of the velocity is 10. The only thing remaining is now to find the unit vector. Okay. So to find the unit vector of the velocity, you can see that since velocity is displacement upon time, it basically means that velocity and displacement are parallel vectors, or more specifically they are lying along the same line of action. So if two vectors are parallel, it means their direction is same, so their unit vectors must be the same. So v cap must be equal to s cap. So v cap is nothing but s cap, which is displacement upon magnitude of displacement, which is nothing but 3i cap plus 4j cap divided by magnitude of 3i plus 4j. So that in turn solves out to be so that in turn works out to be 3i plus 4j upon 5, or you can write it conveniently as 0.6i cap plus 0.8 j. So the unit vector of velocity is so much, and the magnitude of velocity we had already seen was 10 meters per second. So now combining the results, you can see that the velocity vector with the magnitude multiplied by the unit vector, so it will be 10 meters per second multiplied by the unit vector 0.6i cap plus 0.8. So thereby we can denote that the velocity is 6i cap plus 8j cap, expressed in meters per second, provided the speed was also expressed in meters per second, which is in fact the case. The example number 5. 5 is just that a person is pushing a box kept on a horizontal surface with a force of 100 Newton, okay, and the force is directed at a particular direction shown. So you have to just find the vector notation. So question number 5. Force is applied such that it's along this line. So given that the magnitude of the force is 100 newtons, you have to express the force F in terms of unit vectors. What has to be done over here? Let's understand this. This is 100 Newton. So when it comes down to finding the components, dropping a perpendicular here and here, you can see that this component is 100 cos 45 or 100 by root 2 or 50 root 2, right? And this component here is according to this triangle 100 sine 45, that is 100 by root 2, that is 50. Okay. So you can see that the x component of the force is plus of 50 root 2, whereas the y component of the force is minus of 50 root 2 because it's lying along the negative y-axis. So you can see that the force expressed in component form will become fx I cap, that is 50 root 2 I cap, plus fy j cap, so that is minus 50 root 2. Or we can say it is 50 root 2 into I cap minus becomes the solution to problem number 5. Okay, next we'll pick up problem 6. So very elementary problem. It says that the horizontal component of a force 10 newtons inclined to the vertical at 30 degrees is equal to how much? Okay, so the statement of the problem is like this, that find the horizontal component of a force F, where magnitude of F is 10 newtons, okay, inclined to the vertical at 30. You have to find this out. Alright? So very simple. Let's consider vertical to be this particular axis, y-axis, let's say that is the vertical, and x-axis, that is the horizontal. Now the force we are talking about would be inclined at 30 degrees to the vertical, so it would be, let's say, something like this. So this is the force. It has a magnitude of 10 newtons. More importantly, it's inclined at 30 degrees to the vertical, right? So when we break it up into components, you can see that this is the horizontal component and it is 10 sine 30 degrees, and this is the vertical component and it is 10 cos 30 degrees. Right? So you can see that the horizontal component of the force is 10 sine 30 degrees or 5 newtons. And that is the particular question which has been asked. Right, so that's the conclusion of the 6th problem. Right, now let's come to the last one, the 7th one. So the 7th problem says that a planar body has perpendicular axis OX and OY marked on it and is acted by the following forces. Okay, so let's say these are the axes that are marked on a particular planar body. Okay, now the following forces are acting on it. So forces acting on a body are F1, let's say, which corresponds to 5p in the direction of OY. Okay. Then F2, which it corresponds to 4p along OX, right? And the third force, which is 15p, it is along a line AB. Oh, sorry. Yeah, AB, where E is given by the coordinates 3a, 4a, and B is given by the coordinates minus a, a. And finally by a fourth force, which is 10p in magnitude, and that is along OA. So we want to find the net force acting on it, okay, which is the vector sum of these four forces. We want to find Z. Okay. Right. So basically, what we do here is, based on the information that is given, we can express the four forces in component algebra. Okay. So let's begin by that. So as you can see, the force F1 is along the line OY. So F1 would be a force in this direction, and its magnitude is 5p. Okay. So thereby I could signify F1 as, let's write it here. So F1 will be signified as 5p JK. Right. Similarly, the force F2 is 4p along OX. So it will be in this direction. Its magnitude is 4p. So F2 would be 4p I cap. F2 is done. Now F3 is lying along the line AB. So first let's locate the points A and B. So E is a point which is 3A, 4A. Okay, so let's say E is a point here, and B is a point which is at minus A, A. So that is, let's say, some point over here. Okay. So the line AB, this is the vector AB. So you can see that the vector AB would be minus A, 3A. So it would have an x component of minus A to 3A, so that's 4A. So it would be 4A I cap. Right? And similarly, the y coordinate of that point is 4A, and the y coordinate of this point is A. So A to 4A, this would be 3A. So that is 3A. Okay. Now since we are going to be talking about a velocity along this direction, let's take a unit vector along this direction as n cap. Okay. So let n cap is the unit vector along AB. So by that logic, n cap would be the vector AB divided by its own magnitude. So that is 4A I cap plus 3A J cap divided by magnitude of 4AI plus 3. So as you can see, that would become so that would simply work out to be so we would say n cap is 0.8 I cap plus 0.6. So the unit vector that lies along the line AB is given by that. So now when we discuss about the force F3, since we're talking about F3, it is a force of magnitude 15p along the line AB. Right, so we can say that F3 as a vector is 15p into n cap, because n cap is the unit vector of the line AB. So the direction of AB is given by that, and we just calculated. So the force F3 thereby becomes 15p multiplied by this unit vector, 0.8 I plus 0.6. Okay. So as you can see, F3 will become 12p I cap plus 9p. That's the force F3. So in this particular diagram, the force F3 would look something like this. That would be parallel to this line. magnitude is 15p and it's lying along this same unit vector n cap. So that is our force F3. Now similarly we'll come to the force F4 in the end. So F4 was a force of magnitude 10p along the line OP. Let's understand that also. Alright, so let's look at this again. So A was the point somewhere here, which was given by 3, 4 or 3A, 4A. OA would be this vector, okay. And let's say a unit vector along OA is denoted by the symbol M cap. So as you can see, the vector OA is 3I cap plus 4j cap. Now let's say that M cap is the unit vector along OA. So M cap is nothing but the vector OA divided by its magnitude. Okay. So that would give us M cap equal to that would again be 3A I cap plus 4A J cap divided by 5A. So our unit vector M cap is reducing to 0.6 I cap plus 0.8. The case with M cap. So basically we followed the same procedure that we followed for finding F3 earlier. That first determine the direction as per given in the diagram or in the question, that it is along a particular line. In this case it is OA, in that case it was AB, right? So then given the coordinates of the 2 points, in this case O and A, so O is the origin and A's coordinates are given to us, we find the vector OA, and from the vector OA we can find the unit vector along that line, which in this case I have expressed as M cap. So once we know the unit vector, we know the vector F4 because its magnitude is given to us as 10p and its direction is along OA, so its unit vector should be M cap. So keeping that in mind, now see that the vector F4 should therefore be 10p into M cap, that we know. So that is 10p into 0.6 I cap plus 0.8. So just solving this through, you can see it is 6p I cap plus 8p. So this becomes a vector F. Now our original objective, remember, was to find the net force, which was sum of all these forces. Okay. So we have expressed F3 as this, we have expressed F4 as this. Earlier we had expressed F1 as 5p J cap, and we had expressed F2 as 4p I cap. Okay. Now when you sum up all these, you can see that the x components are 4p, 12p and 6p. So that is 22p I cap. And the y components are 5p, okay, plus 9p plus 14 plus 8p, that's 22. So the net force be expressed as 22p into I plus. So what you can see that the net force will be a force like this, which will be of magnitude 22 root p, and multiplied. So that becomes the expression of. Alright. So with this we complete the session for component algebra, which is the second session. So